We say that object data flows in a pipeline. Imagine this data as a liquid that's flowing down a pipe network. The source of this liquid is the base object in the modifier stack, containing that object's creation parameters. The liquid passes through different rooms, if you will, where computations can take place in a linear order. What pours out of the pipeline in the end is what we see in the viewport. So object data flows in a predetermined order that you see in this diagram. It begins at the bottom and flows through these rooms, as I call them, to the end. So let's go through it. As I said, object data begins with the creation parameters. In this example, it's the box primitive. It then flows onto the object modifiers, and these are in object space, or OSMs for short. They're evaluated in the order that they appear in the stack. So twist is evaluated first, and then bend. But subdivide is a world space modifier, and it's a different kind. It will be evaluated later in the object data flow. Watch what happens if I try to take subdivide and drag it down here and place it between the base object and twist. It just doesn't happen. World space modifiers have to be evaluated later, after all the object space modifiers have been calculated. So going back to this diagram, object data then flows onto the transforms. And that means move, rotate, and scale. Now it doesn't matter what order you apply the transforms to your object. I can move this, I can rotate it, and I can scale it. And I can do that any number of times. It doesn't matter. That's because the transforms are stored in a transformation matrix that's evaluated instantaneously in this room, as I call it. Moving on, the object data goes on to space warps, and that includes world space modifiers, which are a subset of space warps. Now, space warps are only available in Max. They're not part of Viz. But Viz has world space modifiers. So that's where we're getting this subdivide modifier. It's evaluated now. And I don't have any space warps here in the scene, but they would be evaluated concurrently. Finally, the object data flows on to the object properties, and this is what gives the object its unique name and color, among other things that you can access in the properties dialog here. You know that because when you make instances, each instance has a unique name and color, right? That's because of the object properties that are evaluated last. It's important to understand how instances work with object data flow. I'll instance this object, and we say that it's part of an instanced pipeline, and the typography here gives us a clue. You learned earlier that instance clones share the same parameters, and we can see that the word box appears in boldface type. And if I make a change here, we see that both of the instances are affected. But what might be surprising is the fact that the object space modifiers are also part of the instanced pipeline. Changes that I make to them are shared. In instanced pipelines, object data branches after the object space modifiers, but before the transforms. That should make sense, because you know that each clone can have its own set of transforms, its own position, orientation, and scale. But what's kind of peculiar is that the object modifiers are part of the instanced pipeline.